All right, take a minute and just read problem one and part A. Okay, put the video on pause, read it. All right, welcome back. Thanks for doing that. It says, you're getting a certain amount of money per day, right? $100 per day. And you're going to spend some because you're just seeing all this money in the filing cabinet. And it says that you're spending the money at a rate of S. So this first part is a little weird when it says, let M be the number of dollars you have in the filing cabinet and T be the number of days since you've been receiving the money. Assume that it's continuous, blah, 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 differential. We're supposed to write dm dt in terms of S. Okay, so here's my part A's effort. Okay, the rate at which the money is changing in the filing cabinet, the amount of money in the filing cabinet is changing, is $100 per day is coming in, right? And we're spending at a rate of S per day. So if we just, take 100 per day minus S per day, that's the rate at which the money's changing per day. It might feel uncomfortable because so far we haven't seen anything about like directly proportional to and all that kind of stuff. That's coming in part B, okay? Part B says that S is directly proportional to the amount of money that we have. So if S is directly proportional to the amount of money we have, that's how I'd write that equation right there. Okay. So it says, write an equation that expresses this fact, then substitute that result into the differential equation. So I'm going to take this Km business right here, okay, and I'm going to substitute it in for that S right there, okay. That really improves things because now I have an M in my equation. Before I did not have an M in my equation. So now I've got, this M right here, which is fantastic. I can't just add Km to the other side, and multiply by dt because it would be a mess. Let me just do it real quick. Like if I'd have, Km plus dm dt is equal to 100, and then I decide to multiply everything by dt, I'd have Km dt plus dm equals 100 dt. Now I've got dt's on both sides. You might say, well, okay, then you're going to move this dt to the other side, but then you'd have a M on the other side. It just leads to disaster. So here's what we're going to do. I'm not going to do those steps. I'm not going to add 100 or Km to both sides. I'm going to divide both sides by this quantity. So it's going to come to the other side of the equation, 1 over 100 minus Km. And then I'm going to multiply both sides. There would be a 1 over here on the right side, right? Let me just do that real quick. Okay, so I got dm dt equals 1. So I just divided both sides by that. Now I'm going to multiply both sides by dt. So the right side would be 1 dt. You probably don't need really the 1 there, but I'm going to put it there. And I'd have 1 over 100 minus Km dm. Okay? I've separated the variables. That's how all of our differential equations are going to go. We can separate the variables. Now I'm going to take the antiderivative of both sides. So the antiderivative, okay? On the right side, we definitely have a t plus some constant, right? On the left side, gosh, it's a little bit more complicated, right? And you got to remember, k is just a constant. So let's let u equal 100 minus Km. So that would mean that the derivative of u would be negative k dm. Okay. Now, why is that going on? Because the derivative of negative k times x would be just negative k. We would have over here du dm, but I'm moving the dm to the right side of the equation. Now I need a negative k right in front of my dm, negative k right here. So I'd have to have a negative 1 over k out front, right? So that substitution would allow me to consider this guy as just like u. And the antiderivative of 1 over u is the natural log. So here's what's going to happen next. I'm going to put down 1 over k with a negative because that's that factor right there is just going to ride along, right? Then I'm going to have natural log of 100 minus Km. Okay, so I'm going to put absolute values around it. 100 minus K m. I don't like how that equal sign is sticking right next to the m. So let me fix that real quick here. So I'm going to have minus k m absolute value bar equals. Okay. Whoo! Wow, that's looking pretty complicated, right? And keep in mind, our whole purpose here is to get a function for m. So let's move the negative 1 over k to the right side of the equation and then write it as an exponential function, okay? So I could go like this. I could move the negative, by multiplying both sides by negative k, I get negative k times t plus c. And then I'd have over here a natural log of 100 minus km. And then I would raise both sides to the, I'd convert it to exponential form, I should say. That's probably clear if I do it that way. So what does this mean? It means e to that power. So e to the negative k t plus c is all equal to 100 minus k m. Okay. Now I'm not out of the woods yet. I got to still find my k value. I got to find the c value. And in video 2, I'll walk you through how to do all that. Okay. Thanks for watching video, or whatever this is. This is video 2. In video 3, I'll walk you through how to find the c and the m value. Okay.